Today we're going to visit pyramid of volume. Now, the very first thing I want to do is explain to you the difference between a pyramid and a prism so that you will know what it looks like. The main difference between a pyramid and a prism, we talked about that the prism has two bases and they're equal and parallel to each other, right? Prism has two bases. The pyramid has one base. Pyramid has one base. Okay, it's still named for the shape of the base. So we can have a rectangular pyramid where the base is a rectangle. We can have a triangular pyramid where the base is a triangle. Okay, these are harder for me to draw, but we will do it. Let's draw a rectangular pyramid. Here we go. Rectangular pyramid. Notice that we have one base and all the sides come up to a point at the top. And you can remember pyramids. I mean, they look like the Egyptian pyramids. Okay, so just remember that the difference between a pyramid and a prism are the bases. Okay, prism has two bases that are parallel to each other and are equal to each other. Pyramid just has one. Okay, the cool thing about the volume of a pyramid, I will look and see if it's like this on the formula chart. But remember, we find the area of the base times the height of the pyramid. Remember that? But, and this is for a prism. For a pyramid, we take it times 1/3, or divide by 3 is the same thing. Okay? Now remember that the height has to be perpendicular to the base. So let me see if I can make that clear here. This is not the height. This is not the height. These are slant heights. This is the height. It has to come from the point and it's perpendicular to the base, which is right here. This is our base. Okay, the height has to be perpendicular to the base. So 1/3 base times height. Let me check this. Look underneath the volume of a pyramid, sure enough. Okay, and a reminder that the capital B is not just a base, it's the area of the base. Okay, capital B. And then the 1/3 could be the same as dividing by 3. This is what I like to do. Okay, same thing. The end. So let's look at one of these, or a couple of them. Let's look at number 1. We're in the new packet that you should have gotten in your email. We're going to look at number 1. And just like they did in the last packet, they're going to start you off slow. So number 1 already figured the area of the base for you. So the height, it says, is 7 inches. And it already said that the area of the base is 105 inches squared. And I want you to find the volume. So in this case, it found the area of the base for you. So in place of the area of the base, we're going to put 105 times the height times 1/3. Okay? And so we should get 35 times 7.
245?
Probably. Sounds right.
Oh, no, it is not. I did not do
What did you say it?
245?
Yes, 245.
245.
It is?
What do you think you didn't do?
That little teeny tiny thing. To the second.
Oh, okay. 245 inches, and it will be cubed because we're finding volume.
This one says 2.
The volume? You mean on the area that it gives us? Or on the answer in the back?
No, where it says base area?
Yes, because area itself is figured in square units. Area is always in square units, but when you multiply by the third dimension, then that's why volume changed to 3. Do you see?
Yeah.
Okay, good. I like it when you bring up stuff like that, because if we get that stuff out of the way, you can understand the big stuff. Okay, so looking at page 1, you pretty much know what you're going to do there on page 1. It already gives you the area. Do not forget about the 1/3 on a pyramid. Okay, looking at page 2, same thing. It gives you the base area again. Page 3, you have to find the base area yourself this time. And just look at the shape. Looks like the first 3 are rectangular pyramids. Okay.
So like on number 1, the base is going to be 18.
18 times 12
Okay.
will give you the area of the base, and then times 19 divided by 3. All right. And remember, you're going to have to try to draw some of your own down there in the word problems. Page 4 is the same information. Do you want to go ahead and do page 5 or 6? This is missing page 5 on purpose, all right? I had a page 5 and I didn't like it. Okay, there was too much and stuff that wouldn't be on the GED test, so I took it out. Let's go ahead with the cone. I'm sure you guys can do this. The cone is going to be the same idea. It's just like a pyramid because you can see the base of a cone is a circle and it goes up to a point, right? And so the circle will have a radius.
So it'd be 3.14 times 3, and then we'll get the answer. And then
Don't
we're gonna
forget
times it
the
times
3
9.
squared.
Oh, 3 squared.
Yes. Then you get that answer and then what? Keep going.
And then we get the answer, and then we're gonna times it by 9.
Yes, and then because it comes to a point and only has one base, you said you're going to do pi r squared because that's the big B, right?
Mm-hmm.
And then you said you're going to take it times the 9, which is the height right here.
Uh-huh.
And then what's different with the pyramid where it comes to a point?
Times 1/3.
There we go. Don't forget the 1/3 or the divided by 3. Okay? And it's going to be exactly the same thing. Are we good with cones? Okay. And page 7 is going to be the same thing. Now, I want you to look at page 8 because I'm going to go ahead and give this to you. We may talk about it again tomorrow. But page 8, I want you to look at number 1. All right, and they want the volume. They said use 3.14, okay, for pi. Okay, do you have everything you need in this problem?
Radius and height,
Where's the height?
Yeah, it goes from the center to the tip of the cone.
This is true, not the 25. This is a slant height. The height has to be perpendicular to the base. But if you notice, they didn't tell you what it is, right? So whatever are we going to do? Because we need that height. Do you recognize this shape right here?
The triangle.
Yes, but even more than that, what kind of triangle is it?
A prism.
Mm-mm.
90-degree angle.
Yes, it's a right triangle, okay? And so I'm going to pull it out so we can look at it. We don't know this side. We know this side, and we know this side. Do we know a formula that we can use with a right triangle that I just taught you not too long ago?
Base and height.
Remember this for a right triangle, Pythagorean
Oh,
theorem?
that's a right prism. I'm sorry.
Okay, do you remember Pythagorean theorem that we used only with the right triangle? So we did this about a week or so ago,
Oh, yeah.
and you weren't here for it, but it's relatively easy. This is called Pythagorean theorem. This is used to find missing sides of a right triangle. It will only work with a right triangle, that's all. And the one thing that you have to remember, if you want more details about this Pythagorean theorem, you need to go back to the YouTube video. But the short version is the longest side is called the hypotenuse, and it always has to represent the C. Always. It has to be the C. It's across from the right angle. It's the longest side. The other sides, I don't care. We're going to call this one A and call this one B. They can be interchanged, B, A and B, but this has to be C. Now we're going to put it in our equation, which is called Pythagorean theorem. We don't know the A, so we're going to say A squared plus B squared equals C squared. And all we have to do is get A by itself. Are you remembering this a little bit, Brandy?
Oh, yeah.
Then we had A squared plus, I don't remember this, 23 squared? Somebody, 529 or something like that? 23 squared? There's a little X squared button.
529.
There, good. 529 equals 625. Okay, do you see where we got all these numbers? Okay, then we're going to subtract the 529 because we want the A by itself. Good morning. So now we have A squared is equal to, is it 96? Thinking so. Now this is the part that people usually forget. If I want the A by itself, I have to get rid of the squared. And the opposite of squared is square root. So I'm going to square root both sides. This is where you go to your calculator because there isn't a perfect square of this. And so we have A is approximately 9.8 approximately. Did y'all see how we got that? You find the square root of 96. And your calculator will say square root of 96 is the answer, but use your toggle switch down there above the enter. It's those arrows, and it will change it to a decimal.
Oh,
Okay, do you remember how to find the square root on your calculator? Okay, it's the green and the X squared button. Okay, and put 96 in there equals, and it'll say the square root of 96. Then use your toggle.
Okay, toggle.
So 9.79 something, blah, 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 blah. So I just said 9.8.
Okay.
Okay. So we're through, right? That's the volume? No, it's this. It's this. So I've got 9.8, and this is the height here. See it? We had to stop to find the height before we could find the volume. Right? You had to take a side trip to find this. And now you can do the volume equals pi r squared h, and then we took it times 1/3 because it's a cone. I'm letting you all do this, and we're using pi. It says in the instructions to use 3.14. Is it close? It may not be the exact answer because we rounded right here. So it may be very close.
The base is 25, right?
No, you need the area of the base, which is a circle. So you need pi r squared h, and then divide that answer by 3. Just a little bit off, you said? So you got approximately, the volume should approximately be 5426.13. 12. Did you round?
No,
Okay. And then how does that compare to the back? When we round, yes, the answer on the back, I want to explain this to y'all. This is the answer on the back. This is what we got. Okay? The difference is when we round one of the numbers that we're going to use in the calculation. So your answer is not wrong. Okay, it's not wrong. It's just the way that we rounded this. If you would leave the entire decimal in your calculator and multiply that into the formula, you would come closer to this answer. The more decimal places we have, the closer it is to their answer. But this is good. This is good. Okay, you have a question, Brandy. I can see it.
No, I'm fine.
Oh, really? Okay. And Mary, we're on page, is it 8, guys? Page 8. And the reason that we were there, let me go back through this real quick. It gives you this and this. But in order to use the volume of a pyramid or a cone, we still find the area of the base and we still take it times the height, but now we have to divide by 3 or take it times 1/3. That's the only difference between pyramids and prisms. Okay, so in this case, we just started off with the cones and we did several of them. But when we came to page 8, this is all it gave us was the radius, but this is the slant height. So that isn't the height that we're looking for. We need the one that's perpendicular, right? And they didn't give that to us. So we had to take a side trip. Notice that this is a right triangle. So I took a side trip here. I knew this and this, but I didn't know this side. It's a right triangle, so I know I can use Pythagorean theorem to find this. And that's where we got the 9.8. Are you with me? Okay. And that's why I wanted to bring up page 8 to you. You're going to have to do a side trip and find extra measurements before you can find the volume.
I have a question.
Yes.
On number 2 on the cones, it already on number 2, it gives us the height already
But not the radius.
and not the radius.
So it's going to create a right triangle again.
And this time we would times the 8 times the 6. Or we'd use that same formula, the a squared.
You have to use this to find the radius.
Okay.
So pull, kind of shade and find out where your right triangle is and pull it out
So
like
C
this.
would be 6 feet.
C would be the 8 feet. See, where's the right?
That's right.
Do you see it?
Okay.
Mm-hmm.
Yeah.
It's always the longest side. And when you have questions, we'll answer those as you get there. Let's stop there. The next one is simply spheres. And if you guys want to move on to spheres and hemispheres, that's fine with me. But let's just deal with pyramids and cones. So let's go through page 8. And then tomorrow, Mary, you might want to go on and I'll answer about the spheres, okay? But because you're taking your test tomorrow. But the rest of you just go through page 8. That's fine. I think that's enough to deal with today. Okay, and also in this package, Mary, I told them that page 5 is missing on purpose. I put it in there in the beginning and it had a bunch of stuff you don't need to know. So I took it out. Any other questions? Or are you ready to tackle this and see what you know and what you don't know? All right. Good, good, good. Volume. Okay.